Hey GED students, it's GED question of the daytime, and we're continuing to build up your algebraic reasoning skills by talking about inverse operations. So let's take a look here. It says, which number could replace the question mark to make each statement true? So let's take a look here at statement A. Statement A says question mark, or some number I don't know, minus 5 is equal to 22. So I'm asking you, what number minus 5 is equal to 22? From what number would you have to take away 5 to equal 22? Now, a lot of you brilliant people, and good for you if this is you, have the number 27 pop into your head. But when I ask you where that number came from, people aren't sure. Some people, the number just comes to them. Some people guess a number and check, like going to, okay, well, maybe it's 26. Let me take away 5. 25, 24, 23, 22, 21, and they go, oh, that 26 is too small, maybe I'll try 27. They use a method just like this. But what could I do besides guess and check, or just being the lovely, brilliant person whose numbers pop into my head? Well, guys, when you don't know part of the question, you can always use an inverse operation. So what do I mean by that? I mean, I'm not sure what number. Take away 5 is equal to 22. So what I could do is I could put those two numbers back together. I could take 22, that would have been an answer, add on the 5. The opposite of subtraction is addition. So I could add on the 5 and see that, of course, it would have to be 27. And 27 take away 5 would be 22. So next one, a little easier for most students. 17 plus what number equals 21? Students find this easy because they can just count up. They go 17, 18, 19, 20, 21. And I just counted on my fingers and realized, well, of course, that would have to be 4. But once again, I want to show you that I could have used the inverse operation. I could have started with 21, taken out that number that I did know, 17, and I would have seen, of course, that that's 4. Similarly, looking at C, I'm asking what number, and don't freak out, oh my God, it's a fraction. Remember that a fraction bar means the same as divided by. So I'm asking you what number divided by 3 is equal to 6. What number divided by 3 is equal to 6. Now, if you know your times tables, you know that that number is 18. Why? Because, again, if I did the inverse operation, the opposite, 6 times 3, the opposite of division is multiplication, so I can multiply that 6 and that 3 back together and see that that total place that I would have been starting from was 18. So 18 is the number that could replace the question mark here. Let's take a look at D. Again, I'm saying 5 and parentheses paired with proximity, meaning if the only thing between two numbers is a pair of parentheses, that's what I mean. Parentheses paired with proximity means multiplication. So right here I'm saying 5 times what number is equal to 35? 5 times what number is equal to 35? Well, of course, 5 times 7 is equal to 35. And again, that could have been done using the inverse operation. I could have started with what was the answer, 35, divided out the factor I knew, 5, and I would have gotten 7. Wonderful. So E might be a little trickier for you. I'm saying what number squared? We say that little floating 2, not as 2. We say squared, or we say the second power. So I could say what number to the second power equals 21. Now, remember what it means to raise a number to a second power. Like, for example, if I said 3 to the second power, I'm not saying 3 times 2. I'm saying 3 times itself twice. So 3 times 3, or 3 times the number itself. So that'd be like 9. So I'm looking for what number times itself is equal to 121. Well, let's get a lot bigger. Obviously 3 was way too small. Like, for example, 9. If I squared 9, I'd be timesing 9 by itself. 9 times 9, that'd be 81. Still too small. 10 squared. 10 times 10 is 100, still too small. 11 squared, 11 times 11 is 121. So what number squared equals 121? Why, that'd be 11. And by the way, guys, if you don't have what I call your perfect squares memorized, that's one of only 3 things I ask my students to memorize before taking their GED, the perfect squares up till 15. That would be a really good thing to practice knowing. Anyway, so there's my answer. A was 27, B was 4, C was 18, D was 5, and E was 11. If you have any questions about this or any other GED math topic, be sure to drop it in the comments and I'll do my best to answer it.